today we are going to see the last part of this chapter and also the last subtopic of this subject. We have the Stokes Theorem. Okay. So Stokes Theorem is actually the generalization of the Green's theorem. Previously, we have taken a look about the what we call it, the Green's theorems. Okay, in the second part of the chapter 3, we have taken a look into the line integral and also the Green's theorem. So this is about the line integral, how you are going to find the integration over the curve C for the given function. And then you are going to solve this one, and we have the integration, and you see the direction, whether it is going to be counterclockwise or the clockwise. Okay, so from here, if you have the curve of the parametric function tend to follow the clockwise rotation, then you are going to have the answer will be negative. Okay, so due to clockwise. And the other way around, if the rotation is counterclockwise, then you are going to have the integration over the curve C, the line integral will have a positive answer. Okay. So we have taken a look into this one, and then if you have the curve that is very complicated like this, and if you want to find the line integral for this given piecewise smooth curve, then you are going to portion, what we call it, to portion each part of the line integral. So you are going to have C1, C2, and also C3. Okay. So from here we have go through this exercise, and then the what we call it, the Green's theorems will give you an what we call it, will give you an alternative in how you are going to find the integration for the given curve. Okay, so if you want to find integration over the curve of C for fxy dx plus gxy dy, it will be integration over the bounded region R, delta G over delta X minus delta F over delta Y, the partial derivative over dA. So if you take a look into this one, it will be applicable for two-dimension space only. Okay. And if you were given the vector function of this one, so the line integral by using the Green theorem will having this formula. Okay. So from the line integral, then we turn into the surface integral, how you are going to find the flux over the given surface. And if you have the surface, meaning that it is a surface rather than just the line itself. So the Gauss theorem is actually the generalization of these Green's theorems, by which apart from having the two dimension to be like this, you are going to do the integration in the form of three dimension, okay, space. So let's take a look into how you are going to find the flux integral or integration over the given surface by using the Stokes theorems. So let's say, for example, we have go through this one, the divergence theorem yesterday, and this is the Stokes theorem. What does it mean by the Stokes theorems? Okay. Okay, so this is the Stokes theorem. We would like to find the integration over the given surface, but the calculation will be much more simple as compared to using the surface integral, by which you don't have to divide the surface into the upper part, lower part, and something like that. Okay, so the Stokes theorem, an overview, it is actually a generalization of Green's theorem to three dimension, and it is called the Stokes theorem. So in two dimension, Green's theorem expresses a double integral over a plane region in terms of a line integral over the boundary of the region. And in three dimension, the Stokes theorem will expresses a surface integral in terms of a line integral over the boundary of the surface. So we are interested with the surface. So let's say you were having the vector function f. So in order to use the Stokes theorem, you need to find the curl of f. Okay. So vector f equal to the function of f, g, and h, by which each component is located at I, j, and k component. So we define the curl of S written as curl F, sometimes also written as curl delta having the cross product of F by curl F equal to delta H over delta Y minus delta G over delta Z. So partial derivative for I component, actually you don't have to memorize this formula. Okay, you don't have to memorize the formula because the formula is coming from, if you do the cross multiplication for vector f with the partial, this is the delta of f. So I, j, and k, you put it over here, and then you have the partial derivative with respect to x, y, and z. Okay, so in here, function of f is for the I component, function of g for the j component, and function of h is for the k component. And remember, we have for the cross multiplication, you are going to have the plus, minus, and also the plus sign. Okay. So untuk dapatkan the, what we call it, the curl of f for vector for I component, so kita just tutup column I, so you are going to have this one, cross multiplication. So it will be delta H over delta Y, okay, minus partial derivative for the G function with respect to Z for I. Okay, and then dia boleh jadi plus atau minus. Kalau awak letak minus for this one, okay, kita akan tutup J component pula, because we are going to find the integration with respect to J. Okay, so from here tutup J punya column, then you are going to have delta X over delta H, this one. Okay, tolak delta H over delta X minus delta F over delta Z. Okay. So kalau kita kembangkan samalah, dia akan jadi tambah, this one will become positive, this one will become negative. So dia sebenarnya sama je. Either way, you want to follow the theorem or you want to memorize this formula. It is actually just the same. Okay. But I prefer if you put the negative sign over there, just use the rule of cross product that I have teach you earlier. Okay. And untuk K component, then you are going to tutup pula the column of K. Okay. So tutup the column of K over here. So tutup column K, then nanti awak akan dapat dia punya this one. Okay. So this one. Okay. Partial derivatives of G terhadap X and partial derivative of F terhadap Y. Okay. So you are going to have for the K component this one. So dapat how we are going to solve for this one? Let's take a look into one example involving this one. So cuba try this exercise. Okay. Determine the curl of f is given f function of x, y, z equal to x squared yi plus 2y cube z j plus 3zk. So how we are going to solve for this one? So let me change to my iPad first, and then I show you how to solve for this one. So the curl of F, you are going to have given f x y z. It is actually equal to x squared yi plus 2y cube z j plus 3zk. Okay. So to solve for this one, curl f atau this one darabkan dengan vektor f, I, j and also k. So you are going to have delta over delta x, delta over delta y, delta over delta y and also delta over delta z. So you have x squared y, 2y cube z and 3z. Okay. So for I component, so dia punya curl akan jadi this is I, j, k. X squared y, 2y cube z and also 3z. So kita akan tutup kolom I. So tutup kolom I, you are going to have the cross multiplication for this one. And remember you have the plus, minus, plus sign. So it will become delta over delta y 3z minus delta over delta z 2y cube z. This is for I component. Okay. So buatlah dia punya partial derivative. And then for j component, you are going to tutup the lubang for j. Okay. So tutup lubang untuk j. And then dia akan jadi plus, minus sign. Sama dengan negative of having the cross product for this one. Okay. Delta over delta x of 3z minus of x squared y. This is for j. So teruskan untuk k component, what are you going to have? So plus untuk k component tutup yang k. Okay. Cubalah buat tutup yang k, awak akan dapat delta over delta x 2y cube z minus delta over delta y x cube y k. So akan dapat berapa? Tutup kolom K. Okay. Then you will have for the K component. So partial derivative for the first one, you are going to have this one will become 0, this one will become 0 and this one will become 0. So tinggal yang dalam. So dia akan jadi negatif 2y kuasa 3i. Yang ini pun jadi 0. So no j term. Okay. And then plus x squared k. So dapat itulah dia punya jawapan for the curl of f. Oi, dapat tak?
Dapat. Betul.
Yang lain dapat? Bapa ada dapat? Adik-adik lain dapat tak?
Dapat, Doktor.
Adik dapat.
Okay, bagus. Adik-adik.
Doktor.
Dapat.
Dia bukan negatif x square k ke?
Negatif x squared k.
Negatif.
Negatif.
Kan?
Betul, jawapan Elfis. Dia juga orang lelaki yang alert. Payah nak jumpa ni. Okay, betul.
Terima kasih, Doktor.
Okay, sama. Thanks to you for noticing me about that. Dalam slide salah. Slide yang mana salah? Mirul Faizin, which one? Ada yang silap dekat slide?
Dalam slide ditulis I komponen tu J komponen.
Oh, dia silap dekat situ. Sepatutnya I, dia bukan K. Ramai lelaki berguna dalam kelas ni. So, salah yang dalam slide yang ini adalah I. This one. Correct this one. Tu banyak-banyak tulisan dia bagus. Okay. So, minus x squared K. Okay. So, that is the correction. Dia kadang-kadang mestilah perempuan buat silap. Tapi in any ways, perempuan selalu betul. Okay. So let's take a look into the next one. We have done with this one. Okay, done. Okay. So the next one, kita tengok kepada ada exercise. This one you can try by yourself. And then there is the Stokes Theorem. What does it mean by the Stokes Theorem and how you are going to find to solve for the Stokes Theorem. So let S be an oriented surface bounded by a single smooth parametric curve C. So if the component of the vector F, you have F a function of X, Y, and Z. And then you have the function for G and also H for each I, J, and K component. And all of these components will have continuous first partial derivative on some open set containing S. Then the integration or the line curve, integration over the curve C for F dr, it will be equal to integration over the surface S. Okay, so daripada curve C, dia akan jadi integration over the surface curl of F having the dot product with the unit normal vector. So this is the dot product. Okay, and then this is the unit normal vector. So for this one, you boleh refer slide surface integral. Okay, yang mana unit normal vector akan sama dengan delta J over this one, Euclidean length of delta G. So G function akan sama dengan Z minus ZX of Y. Okay, and delta G equal to taking partial derivative of X terhadap G plus partial derivative of Y terhadap G component of I of J and also partial derivative terhadap G for the component of C. Okay. So yang ini untuk dapatkan the unit normal vector, kita dah tengok dekat dalam surface integral. So from here, if you solve the integration over the boundary region of over the surface, then kita akan dapatkan dia punya the surface integral by using the Stokes Theorem. So this is the idea of the Stokes Theorem. Okay. So yang saya tanda pink ni adalah the idea of the Stokes Theorem. So you have to find three things in here. First, dapatkan curl of F. Yang kedua, dapatkan dia punya unit normal vector. And then yang ketiga, buat dia punya dot product. And yang keempat, baru solve the integration. Okay. So first, you have to find curl of F. And then yang kedua, find the unit normal vector, and by using this formula and this one. Okay, yang ketiga, the dot product, settle down for the dot product, and the fourth one also solve for the integration. Okay, find the surface integral for the given vector function of F. Okay, dapat Boleh salin dulu, siapa yang nak salin? Done.
Dan
Done. Okay. So let's take a look into the example. Okay. So the Stokes Theorem, because we do the integration over the curve C, and then you change the integration over the boundary region of S. Okay. So from here, dia akan ada terminology about the direction of C. If C will follow the clockwise rotation, kalau awak tengok ni, dia punya pergerakan dia, counter clockwise rotation, dia akan ada positive direction of C. And then if it is follow the clockwise rotation, then you are going to have the negative direction of C. So normally in solving the problem involving the Stokes theorems, the what we call it, the question will give you an information whether the curve of C is negatively or positively, the direction is negative or positive. Okay, these two. And then example. Let's take a look into how you are going to solve for this example. Okay, so for this example, if S is the portion of the paraboloid Z equal to 4 minus X squared minus Y squared, for which Z is greater than 0, Then the vector function is given by 2zi plus 3xj plus 5yk. Okay. So find the integration over the curve C by using Stokes Theorem. So the questions want you to find CF dot dr, by which we can solve by using the Stokes Theorem, integration over the curve S, over the surface S for curl of F having the dot product with unit normal vector ds. Okay. Yep. So you were given this one, and then you have the given that vector function. So for this one, first thing first, dapatkan curl of F. Okay, that is this one. Okay, and then find the unit normal vector. That is this one. Step ketiga, solve for the dot product. And then step keempat, solve for the integration. Okay. So you were given vector F. This is vector F. Okay. Cuba dapatkan curl F dahulu. Try find curl F. Cuba buat. I need a restroom sekejap. Toilet. Okay, dapat kelas? Hui. So let's take a look in how you are going to solve for this one. Vector f equal to x squared, no, that one, 2zi, okay, plus 3xj plus 5yk. And then you were also given z sama dengan 4 minus x squared minus y squared. So from here, first kita nak dapatkan curl of f. That is equal to I, j and k. Okay. Delta over delta x, delta over delta y, delta over delta z. Okay. So dia akan sama dengan this one is 2z, 3x and 5y. Okay. So tutup satu persatu setiap kolom. So you are going to have for this one, ianya akan sama dengan dapat berapa? Anyone? Bagi saya jawapan. Malas pula nak kira.
5i
2?
campur 2j campur 3k.
Okay, 5i tambah 2j tambah 3k. So yang lain dapat Depan?
Tolak 2J kan?
Tolak 2j.
Tambah 2J.
Tambah.
Tambah.
Tambah. Sorry.
Tambah.
Check balik. Siapa
Tambah.
Okay, so that one tambah. So this is the curl of f. So yang kedua kita kena dapatkan dia punya unit normal vector. Okay, because we are going to use this integration of f dot n ds. So n akan sama dengan nak dapatkan n this one, dia adalah sama dengan delta g over this one. Okay. So g x y z equal to z minus z x y. So equal to z minus 4 minus x squared minus y squared. Z minus 4 plus x squared plus y squared. Okay. This is the g function. Okay. And then delta g.
You read it up from my dream tree. Mama wanted you.
Ambil.
Oi.
Okay. This one equal to delta over delta x. Bezakan partial derivative y squared I plus partial derivative of y for z minus 4 plus x squared plus y squared j plus partial derivative terhadap z plus x squared plus y squared j. Okay. So delta g dapat apa? So dia akan sama dengan partial derivative of each state one, you akan dapat 2xi tambah 2yj tambah k. Nampak Oi, dapat?
Dapat.
Dapat. Okay. So unit normal vector sebenarnya n adalah sama dengan delta G over partial this one. So yang mana ini adalah dia punya Euclidean length. Awak akan dapatkan square root partial derivative untuk I squared square root for this one squared plus square root over Z squared this one. Tapi nanti ianya akan eliminate, kita akan hapuskan. Why I said so? Sebabnya if you refer this one, the slide in the surface integral, so kalau awak refer this slide of the surface integral, so this one slide surface integral. So ini adalah calculation untuk unit normal vector actually. Okay. So this is yang bawah ni adalah macam mana kita tentukan dia punya this one. Okay. Macam mana kita dapatkan dia punya Euclidean length for this one. Okay, daripada partial derivative tu. Tapi memandangkan nanti kita akan buat dia punya integration will be like this, didarabkan. So dianya akan terhapus. That is why kita just cari dia punya delta G only. So you don't have to find the what we call it, the Euclidean length of the vector function. So in this case delta G tadi akan back kepada kita punya slide, this one. So you are going to have this is the delta G. So in here awak akan dapat finally unit normal vector akan sama dengan 2xi tambah 2yj tambah k. Okay. So from here settle down the integration over the bounded region surface, curl of f, okay, curl f dot n ds, dia akan sama dengan integration over the surface S. Curl of f tadi kita dapat 5i tambah 2j tambah 3k, having the dot product. Integration curl of f is 5i plus 2j plus 3k, having the dot product with 2xi plus 2yj plus k ds. So dot product meaning that I darab I, j darab j and k didarabkan dengan k. So settle down that one. Akan dapat integration over S 5 kali 2 10 X tambah 4Y tambah 3. Okay. ds. Dot product. So I dot I equal to 1. J dot J equal to 1. K dot K equal to 1. Okay. Then determine dia punya boundary. Tengok balik refer figure to determine the boundary. And if you refer awak punya region, tapak dia, bawah dia adalah dekat axis X, and also y. So kalau tengok this one, okay. This is dia punya tapak xy 2, negatif 2. Over here. So, senang guna apa? Ada circle. So, we will do integration by using what?
Cylindrical.
Okay, betul. Cylindrical coordinates. Okay. So, what is if cylindrical, you have r over here and you have theta over here. Okay, r daripada berapa ke berapa and theta daripada berapa ke berapa. R berapa ke berapa?
0 sampai 2.
Betul. Theta
0 sampai 2 pi.
0 sampai 2 pi because it takes the whole bulatan. And then dia punya transformation x equal to r cos theta and y equal to r sin theta. Okay. So settlekan dia punya integration. So integration over the curve S 10x plus 4y ds, it will be integration of 0 to 2 pi 0 to 2 10x akan sama dengan r cos. Aduh, ni yang aku menyampah ni kalau dah satu ni. Kan dah hilang, 10 r cos theta, okay, plus 4 r sin theta plus 3. Plus 3 multiply with r dr d theta. Okay. So it will be integration over 0 to 2 pi 0 to 2 10 r squared cos theta plus 4 r squared sin theta plus 3 r dr d theta. So cuba settlekan dia punya integration dapat berapa? Done. Ada yang dapat apa jawapan?
pi.
Yap, betul. 12 pi. Yang lain dapat So equal to integration 0 sampai 2 pi. This one akan jadi 10 R kuasa 3 per 3 cos theta tambah 4 R kuasa 3 per 3 sin theta tambah 3 R kuasa 2 per 2 d theta. Okay. So settle up for this one akan dapat integration of 0 to 2 pi 80 per 3 cos theta tambah 32 per 3 sin theta tambah 6. Okay, d theta. So solving for this one, you are going to have 83 per 3 sin theta minus 32 per 3 cos theta plus 6 theta. 0 to 2 pi. So dapat jawapan dia 12 pi. Dapat Yang dah cuba lagi satu exercise saya dah letak dekat dalam tu. Oh tapi figure tak ada, nanti saya tunjuk dia punya figure. Terlupa nak lukis. For that one. Okay, done. Ui, dah belum? Cos 2 pi bukan 1 ke doktor. Cos 2 pi bukan 1 ke doktor. Apa maksud tu? Bukankah cos 2 pi itu 1? Itu maksud dia. Dapat jawapan sama tak? Cos 2 pi 1, betul? Cos kosong pun 1. So 1 tolak 1 kosong. Okay. And then sin 2 pi is kosong. And sin kosong is also a kosong. That is why hanya tinggal 2 darab 6 theta. This one. Sebab yang ini akan jadi kosong, this one is kosong. This one because 1 minus 1 untuk cos function. Okay. Dapat So very good Amirul Hafizin. Meaning that Amirul is not sleeping in the class. Dan this one, yang lain dapat? Bapak dapat?
Dapat doktor.
Okay, Shimir, Syahrul Aiza, Asirul, Azim. Kita dapat semua?
Dapat doktor, dapat.
Oi. Asal suara kau jauh benau? Macam tengah main bola sambil buat matematik je. Okay Dan, bisa. Kalau section sebelum ni dia kata bisa dapat. So let's take a look into another example in how we are going to solve for this question. Okay, so soalan ni sebenarnya ada rajah tapi saya lupa pula nak letak. Okay, so let S be the rectangular surface shown. So kejap lagi saya lukis. And let C be the rectangle that forms the boundary of S in the plane of Z equal to Y, oriented as in the figure. If the vector function equal to x squared I plus 4xy cubed j plus y squared xj. Find the integration over the curve C f dr. So for this one, awak ada dia punya figure is something like this, x, y and also z. Okay, so you have this one dia berbentuk ibarat cake. Okay, it will be something like this. Okay. So from here you are going to have this is the form of the what we call it, the solid. Okay. And from here you are going to have this one, 1 dan juga 3 dekat sini. And region dia adalah dekat bawah. Tapak bawah ni adalah dia punya region. Okay. So dia punya gerakan adalah clockwise, rotation. So what you are going to have? Dia bentuk macam a pieces of secret recipe cake. Okay. So this is the region. So dia kata find integration over the curve CF dr. So we are going to solve this one using Stokes theorem. So by using Stokes theorem, you are going to have for this one, it will be integration over the curve S, curl of F having the dot product with the unit normal vector ds. Okay, so daripada sini dapatkan curl F. Cuba buat dulu. And then awak tengok the orientation of C is clockwise. C is clockwise rotation. What will be the impact when you have the clockwise rotation? If we are referring to the slide, if you have clockwise the rotation, it will have a negative direction of C, curve C. Okay, refer slide nombor 20 yang ada gambar bulat-bulat. So tapi tak apa, dapatkan the what we call it, dapatkan the curl of F first. Okay, done. Ada yang dapat? What is the curl of F? Ada yang dapat? So F sama dengan vector F you were given equal to x squared I plus 4xy cubed j plus y squared x. Okay. Okay. So from here, let's take a look in how we are going to solve for this one. Okay. Curl of F. So curl of F equal to I, J and K. So delta over delta X, delta over delta Y. Okay. X squared 4x y cube y squared x. Okay. So for this one, to third column I, you are going to have cuba settlekan. Bagi saya jawapan. Malas pula aku nak kira. Cepat. Abang Paat, adik Paat. Dan semua. Abdul Wafi. Ni nama-nama yang tak pernah disebut ni siapa tengok. Asirul Adzim. Benda nama susah benar budak ni. Hafizah.
Asirul Azam tu dia nak buat dia tu.
Betul?
Dia nak buat dia jap lagi dia bagi jawapan.
Okey. Cepat Asirul Azam. Kalau Asirul Azam tak bagi jawapan, Abang Paat akan belanja kita satu kelas McD.
Jangan jawab, jangan jawab.
Saya setuju.
Anyone?
Abang Pak tengah kira tepi saya.
Tidak. Sweetnya lah hai korang ni. Anyone dah dapat? Ada yang dapat tak jawapan? Betul tak? This one. Jayton, Fatih Nur Syuhada, Nur Zafira.
Adik Faris nak jawab.
Cepat. Berapa jawapan?
2YXI
Okey.
tolak Y squared J campur 4Y cube K.
Okey. Betul. Jarang-jarang lelaki betul ni. Macam pelik ni ada pakai apa-apa. Okay. So, betul jawapan Ichad. 2y squared xi minus y squared j plus 4y cube k. Yang lain dapat Awak tutup kolom I. Lepas tu, apa nama? Buat dia punya partial derivative for that one. Okay. Curl of f. So, dah dapatkan curl of f. The second one, find the unit normal vector. So G, X, Y, Z sama dengan Z minus Z X of Y. Okay. So given dia punya function Z awak adalah sama dengan Y. Okay, dia kata Z sama dengan Y. So in this case, dia akan jadi Z minus Y. Okay. So from this one, delta G equal to partial derivative of Z minus Y plus partial derivative terhadap Y, Z minus Y plus partial derivative terhadap Z, Z minus Y. Okay. So akan dapat dia akan jadi sama dengan, this is for I, J and K. So you are going to have this one is negative J plus K. Dapat So that is the unit normal vector. So then dapatkan dia punya the what we call it, the the surface integral, integration over the curve S f dot n ds. It will be integration over the curve S curl f, this is akan ada curl, okay, curl f equal to 2 y squared xi minus y squared j plus 4 y cubed k, having the dot product with negative j plus k ds. So integration over the curve S, okay, yang ini tak ada I component, no need, kita darabkan j dan juga k component, okay. So negative y squared darab 1, j darab j dia akan jadi 1. So it will become negative y squared tambah 4y cube. Okay. D A. Okay, alamak I sekejap. Dia punya vector component akan jadi negatif. Okay. So betul kan The orientation is negative. Tak perasan pula. Since the orientation of C is negative, so integration over the bounded region over the curve C f dot dr equal to integration over the bounded region R curl of f having the dot product with negative and dA. Okay. So unit normal vector n equal to negative j plus k. So negative of n, it will be j minus k. So integration over the bounded region R, okay, for curl f negative n dA, it will be integration over the bounded region R. Curl f is 2 y squared xi minus y squared j plus 4y cubed k, having the dot product with j minus k dA. Okay. So from here buat dia punya cross product. So integration over the bounded region R, negative y squared minus 4y cubed dA. Okay, apakah dia punya boundary of the integration? Sebab kalau awak tengok region dia yang saya colourkan biru tu, dia ada x and then dia ada y. Okay, yang saya colourkan biru, the region, you are going to have this one. Okay. 3 dan juga 1. Ke 1, 3? Dekat Y 3, dekat X 1. Dekat Y is 3, dekat X 1. So berapa dia punya region of the integration for this case? Oi, apa region dia? Anyone get the answer?
X 0 sampai 1.
Betul. Y.
Y dia 0 sampai 3. Sampai 3. Sorry.
Okay, betul. 0 sampai 3. Sebab dia adalah satu segi empat yang very simple segi empat. So we just do we will just follow the region. So awak buat integration 0 sampai 1 and 0 sampai 3. Negative y squared minus 4y cubed dy dx. Okey, cuba settlekan dapat berapa jawapan dia.
Doktor,
Yep.
nak tanya yang curl F tu kan,
Mm-hmm.
yang I komponen tu bukan 2yx ke? Kenapa 2y squared x?
2yx. Selamat ada yang cakap. 2yx, betul-betul. 2yx. Betul kan this one? 2yx. Okey, tak perasan tak? So this one is 2y. X. Okay. It is 2yx. So, tapi sebab I component dia terhapus. There is no I component over there. Okay, thank you anyhow. Ada juga lelaki yang berguna zaman sekarang. Yang perasan and very particular. Okay, yang lain dapat? So, sorry for the mistake. Okay, tapi tak apa. Woman always right. Dia tengok, dia silap. Walaupun silap, tapi akhirnya kita tak gunakan I tu. So, perempuan sentiasa betul. Okay. Ada yang dapat jawapan? Solving for the integration. You will get this one equal to integrate 0 to 1 negative y cube minus 4y kuasa 4 kosong 3 dx. Okay. So akan dapat integrate 0 to 1 negative 90 dx. So it will be negative 90 unit. Dapat yang lain?
Doktor nak tanya.
Silakan.
Yang awal-awal tadi kan, kita nak tentukan dia punya orientation dia counterclockwise ke counterclockwise ke negatif positif tu macam mana ya? Tak clear sangat tadi.
Dia daripada rajah. Yang kalau macam case example this one kan. Dia selalunya by soalan. Soalan akan tentukan. Untuk Stokes Theorem, dia ada this one yang kita kena tahu. So tengok rotation rajah kita tu, si curve ni dia is it counterclockwise or clockwise. See? So kalau dia clockwise rotation, dia akan jadi negatif. Tapi kalau dia arah counterclockwise, it will become positive. Kalau dalam macam contoh ni, dia bagi ianya mengikut this one. Okay, rajah ni memang soalan bagi. Okay, So kita akan tahu dia akan jadi integration over the curve S F dot N. So sebab dia nya adalah positive orientation. Okay, this one. So kalau untuk soalan yang kita bawa buat ni, memang rajah dia bagilah positif. So selalunya for the Stokes Theorem, it will state in the question whether the curve C is counterclockwise or positively orientation or clockwise rotation, having the negative orientation. And then untuk contoh ni sama juga sebenarnya dia bagi dekat dalam rajah. If you refer to this question, so dia ada bagi this one, dia punya orientation of C. Cumanya saya terlupa nak lukis rajah ni sebenarnya daripada soalan in the figure. So sebab terlupa nak lukis, that's why dia bagi daripada dalam soalan. Pasal dia tak keluar pula ni slide aku ni. Okay, dapat Kalau yang contoh yang kita tengah buat.
Dapat Doktor, thank you Doktor.
Nampak tak saya tunjuk rajah ni? Exercise. This one.
Dia start.
Dia start dekat Stokes Theorem Oh, okay. This one. So kalau macam rajah ni sebenarnya memang dia bagi kita lukis. Dia bagi, bukan saya lukis. Ni sebenarnya soalan sekali dengan soalan supposingly. Tapi saya tertinggal lukisan dia. That is why I draw by myself. Actually, the orientation of the curve C, it will be given by the question. Okay. Okay, dapat Very good question daripada siapa tadi? Irsyad. So, this is the answer for this question. Ada soalan tak yang ni? Semua dapat? Hui.
Dapat Doktor.
Okay. Yang ni done. Done So, ini adalah Stokes Theorem and there is also another exercise that I enclosed in here. Boleh try by yourself. So, saya nak tunjukkan the end. Okay. So, saya nak tunjukkan dekat mana kegunaan engineering mathematics and all the theorem that you have learned in this chapter. Okay. So, saya ada letak dekat Microsoft Teams as well as in YouLearn. Apa nama dia? This one. Saya ada letak juga dekat YouLearn slide untuk vector calculus in AMT. Okay, so dia just ada sedikit recap by which you are going to use this vector calculus in electromagnetic system. So if you refer to this one, okay, so nanti awak akan tengok dalam EMT. Kalau Tasha tak tengoklah sebab Tasha already take EMT. Okay, for those who already study EMT. So dia sebenarnya if you refer to this one, ini mewakili vector notation. Okay, but in this case the difference if we have, kalau dalam engineering mathematics vector A saya akan tulis AXI plus AYJ plus AZK. But in this case dia punya vector function, vector direction dia guna X hat, Y hat and Z hat. But it is actually the same with this one. It refers to the vector notation. Okay. So there is one thing that you should know. Tak semestinya vector dia kena guna I, J and K. It depends on the case and depends on the scenario that you are dealing with. Okay, and this is the scalar product or cross product for the vector function. So sama je, awak akan susun yang ini untuk X hat, Y hat and also Z hat for each component of the vector function. So if this example, kalau awak tengok, dia kata dia bagi vector A and then dia bagi vector V and also you were given vector C. So kita nak dapatkan A cross B and then di-crosskan dengan C. So you are going to do A cross B. So in this case you are going to have X hat, Y hat and Z hat. So 1, -1 and 2. Yang B 0, 1 and 1. So settlekanlah dia punya cross product. So 1 darab 1 jadi -1. So you are going to have a plus minus plus sign. So it will become -1 minus 2 for X hat minus 1 minus 0 for Y hat plus untuk Z is 1 minus 0 for Z hat. So equal to -3 X hat minus Y hat plus Z hat. Okay. Then buat pula untuk cross dengan C. So sama je sebenarnya, cuma notation dia yang berbeza. Sama lah macam awak semua kan. Kalau katakan this one. Sekejap saya tengok siapa ni. Mana aku nak klik orang ni? Muhammad, this one, Muhammad Syahrul Aiza. Kalau katakan saya jumpa pensyarah lain, saya cakap, Syahrul. So saya refer kepada Muhammad Syahrul Aiza. Tapi kalau dekat rumah katakan family Syahrul ni panggil dia Aiza. So dia orang mention Aiza. It is actually refer to the same person, Muhammad Syahrul Aiza. So mungkin kalau dengan kawan-kawan dia pula, kawan dia panggil Ijul, kan. So orang yang sama tapi nama banyak berbeza. So sama juga dengan vector function. Dia adalah benda yang sama, hanya dia punya notation for the direction is the one that is different. Okay. Some books using I, J and K, and some of the books it will use X hat, Y hat, Z hat. But as long as it is vector function, all the operation and all the theorem yang kita belajar, it will be the same. Okay? Dapat? So kalau awak nak nama banyak, vektor pun dia nak banyak. Banyak gaya. Okay? So this is the, what we call it? The solution untuk vector function, and this is spherical coordinate system, meaning that kalau kita nak buat integration by using spherical coordinates. So spherical coordinate, if you still remember, kita ada belajar X, Y and also Z. So if you want to find by using spherical, akan ada satu point P. So from here you are going to have Phi over here, and then this is rho, and the angle taking is theta. Okay. So the spherical coordinates will use the same concept as this one. Okay. So this is an extension. Selalu kita cari satu full solid, but in EMT later on awak akan tengok kalau dia jadi separuh je macam itu. So dia jadi lagi susah lah, lagi complicated equation ni. Patut ramai tak score EMT ni. So this one lagi higher level. So you are going to have the surface, and then dekat mana kalau dia ambil separuh tu kita akan tolakkan the full magnitude of this one minus the separuh yang kecil. Okay. Then you are going to get the what we call it, the solid. So this is for example the application of spherical coordinate system. Okay. A sphere of radius 2 cm contains a volume of charge density given by that equation. Find the total charge Q find in the sphere, contained in the sphere. So if you are using a sphere, meaning that it will be something like this. You have the 3 dimension. Okay. So kita boleh guna surface integral. So from here surface integral the change kepada spherical coordinates. Integration by using spherical coordinates. So from here r squared of this one dia akan jadi rho, kalau kita guna rho squared sin phi d rho d phi d theta. Okay. So tapi dalam EMT nanti dia akan guna r squared. So yang mana dia punya kesetaraan rho squared in this case adalah r squared. Theta dia adalah phi. Dan phi dia adalah theta. Okay, that's it. Boleh tengoklah nanti. Nanti kau belajarlah tahun depan. Dalah ni. So is the divergence theorem. So itu adalah lagi satu simbol untuk represent the flux, okay, of the given vector function that we are interested. And also this one example, and this is the Stokes Theorem yang awak belajar tadi. Okay, so this is the Stokes Theorem by which you are going to have to curl of f, tapi dia guna vector function dia sebagai b. Curl b dot ds. Okay. So dot dl yang mana l tu adalah unit normal vector. So ds dia mengandungi dia punya unit normal vector. And ds. Okay, dapat? Senyap je semua? Dah tidur ke tu? Hui. Ada orang ke tak tu?
Ada doktor.
Ada soalan?
Ada.
Tak ada kot, betul.
Tengok suara orang yang matang. Tak ada kot. So yang lain ada soalan? Bapak tak ada soalan?
Ada juga doktor.
Tak ada. Okay, if there is no question, that's it for the